All right, as we continue to wrap up here in Unit 6, we're getting a little preview to Unit 7 this time. Before we get too far, we're gonna kind of blend things a little bit here because exponents are going to become a big thing of what we're doing. So, first part here is a little bit of vocabulary. Okay, when I'm looking at this, if there is a value that I am taking to an exponent, okay, just the x is being taken to the exponent here. So this is my base. You just got me done saying it, but I think you know what this is already. This is our exponent. And in this case, since there's not parentheses around it or anything like that, if there's a number in front of this thing with an exponent, my base, this, I can change colors here one more time, is called my coefficient. Okay? So if they're all separated like this, those are the three pieces when I start using words with stuff. Now, I'm going to add one extra piece in here. We do this sometimes. If that 2x happened to be in parentheses, and then the 5 was here, okay? That would mean that in this case, the 2x would be the base instead of just the x, because the parentheses take this whole thing to that power. But we'll talk more about that as we get into this. But I just want that there for reference for later as we're working these through. And again, if you're looking at this, you're like, I don't have this note packet. It's the same one we've been using. Okay? Still this one starts with systems of equations. So if you need another, they're back on the back table still. Okay, so for today, we're only going to deal with what you see in the screen here, these first two. They're the two, I'm hoping, easiest ones. 0 is an exponent. Okay? Anything to the 0 power is 1. A variable to the 0 power is 1. 45 to the 0 power is 1. I'll even prove it. There it is. And x squared, y to the 4th, x to the negative 5th, to the 0. Because remember, all this stuff when we do parentheses is all grouped together to the 0 power. Is still 1. That's wild, but it's one of those math rules that just, it is what it is. So you're like, sweet, anything to the 0 power is 1. We're good. Okay? Now, when we get to negative exponents, I'm going to add one little box here onto our negative exponents part. So it's like a little growth going here. So when we talk about fractions, the top is my numerator, and the bottom is my denominator. So the reason I mention that, because it's important, is sometimes we're going to have fraction stuff that we got to deal with these. And when that occurs, we end up having to do a little something, so we need to know the language. So move bases with negative exponents in the numerator to the denominator, but there's one more piece. And make a positive exponent. You're like, okay, so what exactly do you mean? Okay, first example here. Anytime I have something, if something's not a fraction, okay, we've talked about this before, I can make it a fraction by putting it over 1. So, negative 3 is not part of this, because remember, the only thing that goes with my exponent is what's directly in front of it, unless there's parentheses. So it's just that x to the negative 2. This negative 3 doesn't move. It stays right where it's at. This x to the negative second, though, that's a base with a negative exponent. We're going to move it to the denominator. It's going to go, and the exponent is going to become positive. So only the part that has the negative exponent on it moves. Okay? Let's keep playing. Let's keep playing. I know I'm not here to kind of take things as we go, but let's keep playing. So you're like, okay, well, wait a minute though, Hardy. Now it's down here. Does that matter? It does. Move bases with negative exponents in the denominator to the numerator and make a positive exponent. So same rule. If things are positive exponents, we leave them alone. If they're negative exponents, we move them, we flip them. So in this case, on this one, x to the fifth power is a positive exponent. I don't need to move it. It's being good. It's behaving. It's being positive. However, my y to the negative second not being positive. So it needs a new outlook on life. And no, it is not time to leave. This y goes to the top and becomes positive. You're like, well, what happens to what's down here then? Well, if everything's in the numerator, that's okay. If you wanted to put something in the denominator, you could put a 1. It wouldn't hurt, but you don't have to. And so when we're doing this stuff, like here, now that's blow your mind time with our last one here. Then we're going to do some practice ones together. Well, what do I do if it's out there and there's stuff in parentheses? If there's parentheses, this is going to go to both parts inside. So the x is going to get the negative 2, and the y is going to get the negative 2. We distribute it. And in this case, since our rules tell us if it's a negative exponent, it gets flipped to the other place, this is going to go from the numerator to the denominator, from the top to the bottom of my fraction. And my y to the negative second is going to go from the bottom, the denominator of my fraction, up to the top, become positive. Only positive exponents in answers, okay? Answers only have positive exponents because we want to have positive vibes. Excuse me. So that's kind of our start, our basis, as we start to get into this, as we move ahead. So again, if you need to, go back and rewind me. If you need to look at some parts, I'm going to do some of the practice ones here. But that's the nice thing about looking at me on video. You can pause me, you can rewind me, you can do whatever you need to me. But we'll be referring back to these. Because we're going to be on page 5 and 6 in the practice packet. We're in the practice now. And I'm going to do some of the ones I got dotted here. So, okay. Rewrite using only positive exponents. No decimals. Okay. That's got to get flipped. Well, I don't see where I can flip it. Oh, yeah, I can make it a fraction. So this, to become positive, needs to get to the bottom of my fraction. But Hardy, there's nothing left in the top now. Put a 1 there. Okay, if you ever move stuff and there's nothing left, whether it's the numerator or denominator, you can always put a 1. And with a fraction like this, you need to. Because if you don't, we would assume that x to the 6th is on top, and we don't want to do that. So again, if you wipe stuff out, stick a 1 there. But do not flip stuff that is not negative. Like here, that 3, that's not negative, it's positive. It is minding its own business. Leave that thing in the numerator, it's being good. X to the negative 2 being negative, flipperoo. y to the negative 7, not being good. Flip it to the denominator. All positive, nothing but positive vibes. We're good. Okay? Exponents, exponents, exponents are all that we're looking at. I don't care if the number's negative. Don't flip that. That we flip. That's a negative exponent. That is not a negative exponent. Don't flip it. Check your answers as you go. Okay? Or I look here and I go, okay, y to the negative 8th over 3. Let me make my fraction here. Y to the negative 8th need to flip? Yeah, it's got a negative exponent down at the bottom. Does 3 need to flip? No, it's behaving itself. Leave it alone. I got nothing left up top. I'm going to put a 1 there. So you see how we keep just all we're doing every time. Not a negative exponent. Leave it alone. Negative exponent. Flip that sucker. Positive exponent. Leave it alone. Negative exponent. Flip that sucker. We're good. So just a little bit of insight, a little bit of a start into that part. So then review stuff. Okay, well, we always got to do some of these. Now again, these are different. This one, they're both in y equals. Just set them equal and go. Okay? You have an example like this in the notes when the y's are equal. So use it. I'll even show you. Okay? When both equations are y equals, set them equal. It's on page 2 of your notes. Go use it if you need to. But this one, I only have one equation that's y equals. So it goes in there for y. Step 1. Copy that second equation until you get to the y. But I know what the y is now. And I plug it in. Now that I've got it plugged in, I'm going to simplify this. The 4x does not have anything to do with the parentheses. So I'm going to multiply this through. Ooh, that's a big number. And here's one of the places that we had issues on the quiz, so I want to make sure that we take care of this now. This is not like this one where the x's are going to be on opposite sides, and I need to do opposites. My x's are on the same side of the equals. So we're just combining them. 4 and 48 is 52. Now we're back to first semester Algebra 1 business. I want to get the 52x alone. I'm going to do the opposite. Always got to be the opposite if they're on opposite sides. And one last step to get x, but we're not done. Not quite. Okay, again, if you're looking for an example, that same note page, page 2. Down here at the bottom, we got this. If you don't have that, get it off of Classroom. It's on the front page. Update your notes, people. Okay, almost there. Last step. Take this equation, keep going until you get to x. When you get to x, plug it in. Replace x with its value. And find your answer. This is why we do these spirals, so they stay fresh in our minds, so we keep working ahead and making sure that we do this well. But you've got to practice to get better at it. Just saying. Just saying. Solve by elimination. Again, you have this in your notes. If you can add straight down and eliminate something, page 3, right there. Okay, do that. But What happens if I add straight down and nothing cancels? Do I quit? No. Do I write no solution? No. You know what we're going to do? We're going to find something that looks like, oh, we got to multiply by something. Okay. Can I do 6 times something and get 9? I don't know. Let's try 6 times. Uh-oh. No, I can't do 6 times something and get 9. Okay, I can't do that one. What about 10 and 20? No. Ooh. Okay. We're going to multiply that top one by 2. Hardy, why not negative 2? That's a legitimate question because we've done that a few times. Here's the answer. When I distribute positive 2 this time, okay, make sure it goes through to all 3 of your terms. And I copy the one on the bottom, and I go to add. Negative and positive 20. The signs are opposite already. I don't need to make the signs switch. So I can make the y's go away. Negative 12 plus 9 is negative 3. 40 minus 10 is 30. And just like that, we are one step from being done with x, not with everything. Step 1, we got that out. Step 2, we solved for x. Last step. Step 3. This has just been me so far. I'm going to just stay consistent. I'm going to take this top equation before I multiplied it. I'm going to start copying it until I get to the x. When I get to the x, I'm going to replace it with the negative 10. Everything else up here stays exactly the same. But by replacing that x with negative 10, now I can figure out what y is. Multiply those together. We're working on getting y by itself. What's the opposite of a positive 60? A minus. Ooh, excuse me. And divide. We're not adding. We're multiplying y by 10. The opposite would be to divide. And I've got my solution. Okay. For the inequalities, I'm only going to do one line and I'm going to shade it. I'm not doing the other line. I'm not doing the combo part. If you need that, go back to your notes from yesterday. Page 6. Or watch the video from yesterday. So, here's what I will do. Okay, first things first. Y-intercept, y-axis, 2. My slope is 1/3. Up 1, right 3. Now I'll go a little off the graph here, up 3. Since it's just a line, it doesn't have a line under it, that's going to be dotted. And since the arrow is pointing at y, we're going to shade below. So you're going to do that for the other one, and then in the spot where they overlap, you're going to shade that in and be ready to go. Okay? So hopefully you have checked this video out. I'm assuming that's going to be the case because we are going to be continuing on the next time we get together with our exponent rules, adding a few more, and getting ready for the next quiz. We'll see you then.